Hey guys, so here we are with another video of some example problems from worksheet 2. And in this video, I'm going to focus on the absolute value type of problems, starting with number 6 from worksheet 2. The idea with the equations for the absolute value problems is this. The inside of this absolute value has to equal the number 3 in order for the answer to be 3 when I take the absolute value. However, there is another option. If the inside of this equals positive 3, and I take the absolute value, I get positive 3. But if the inside of this equals negative 3, and I take the absolute value, I also get 3. So I have to set up two scenarios. Scenario 1 is that the inside of the absolute value equals 3. But scenario 2 is that the inside of the absolute value equals negative 3, because I still will get the right answer if that is the case. So let's solve both of these equations. To solve the first equation, I'm going to multiply 4 over to the other side. I get y minus 6 equals 12, and add 6 over, I get y equals 18. So that's one possible answer. Going for the other problem, if I multiply 4 to the other side, I get y minus 6 equals negative 12. Add the 6 over, and I get y equals negative 6. So there's two answers to this that would work. That was number 6. Let's move on. We are now going to do some absolute value problems with inequalities symbols. So this is number 14. We have the absolute value of 3m minus 2 is greater than 4. So this is a greater problem, greater than. So I like to write it out like this, or, which means it is greater. It's an or problem. So what I'm going to do is I'm going to say this. Okay, the inside of the absolute value, 3m minus 2, it has to be bigger than the number 4, or it could also be smaller than negative 4, because if I pick a number smaller than negative 4, like negative 10, and then I take the absolute value of it, I get positive 10, and positive 10 is greater than 4. So the other scenario is to take 3m minus 2, flip the inequality sign, so from greater than it flips to less than, and negate the number. Positive 4 turns to negative 4. So you flip, you negate. That's how you set up these or problems. So solving, I add 2 over, so I get 3m is greater than 6, so m is greater than 2, or add the 2 over, we get 3m is less than negative 2, so m is less than negative 2/3. So to get my final answer in interval notation, I like to draw the picture. There's a line over here to draw the picture. So we have m is greater than 2, or m is less than negative 2/3. So here's negative 2/3, here's 2. These are non-inclusive, so I'm going to draw open circles. Those are going to translate into parentheses in my final answer. Greater than 2, or less than negative 2/3. There it is. And so final answer is going to be negative infinity to negative 2/3 with a parenthesis, union 2 to infinity. The or problems will always have two chunks or two intervals in your answer, whereas the and problems will always be in between the two numbers. So that is a greater problem. Let's do a less than problem, like number 16. Number 16 is 2x plus 11 is less than 5. And I like to say less than, because it's an and problem. Okay, so I like to set these up personally as I call it a sandwich problem. So I take the 2x plus 11, that's less than 5. It's also going to be greater than negative 5. So I could also say, and 2x plus 11 is greater than negative 5. Flip and negate, just like we did for the or problem. But I actually like to just write it like this. This means the same exact thing. I like to basically say that the 2x plus 11 is going to be sandwiched between. So to sandwich, you do two less than symbols, one on the left of it and one on the right of it. in between -5 and +5. That's the way that you want to set this up. So I just solve. I'm going to subtract 11 to everything. Every side, I get -16 is less than 2x, which is less than -6. And divide over the 2 to everything. The 2 itself is positive. I don't have to flip any signs. So -8 is less than x, which is less than -3. In other words, x is between -8 and -3, and this is non-inclusive. So let's go to our number line and graph this. So we have -8, we have -3. Non-inclusive are going to be open circles, which are going to translate to parentheses. And I write my answer in interval notation, which is going to be parenthesis -8, comma, -3, parenthesis. If these were underlined, I would have brackets instead. The circles would be filled in. So that's the deal. What do you guys think? Hopefully it makes sense. And I have one more problem to do. It's a special case. So reminder that if the problem starts out looking like something like number 19, you're not allowed to do the less than or greater or until the absolute value, excuse me, part is by itself. So in order to get that by itself, I need to subtract over the 8. But there's a huge red flag that should be going, or an alarm going off in my head. And it's that I have a negative number on the other side. I'm not allowed to have an absolute value with a negative number. If it was an equal sign, it would be no solution. But it's not an equal sign, it's a less than sign. So we really have to think about that. We really have to think. Either my answer is going to be no solution, or it's going to be all real numbers, or infinitely many solutions. So let's think about this. I hope you guys could agree with me that no matter what, this left side is going to be a positive number. Why? Because I'm taking the absolute value. So no matter what the number is inside of the absolute value, when I take the absolute value, it becomes positive. And so any positive number, is it possible for a positive number to be less than -6? The answer is no. This is never going to occur. It's impossible. So this is never going to happen, which means this is a no solution. Okay, if it was a greater than symbol, it would be all real numbers because a positive number is always going to be greater than a negative number. But this one, no such luck. This was a no solution. So that's it for the absolute value problems. Hopefully that helps. Thanks, guys.